In this video, I'll be solving the second problem of UPSC Civil Services Mains 2023 Statistics Paper-1. So we were given x, y, z be three mutually independent standard exponential variates, and w1 is equals to x plus y plus z, and w2 is x plus y by x plus y plus z, and w3 is x by x plus y. So we need to determine the joint distribution, marginal densities, and we also have to examine the mutual independence of w1, w2, w3. So first, so they have mentioned that it is standard exponential variates. So that means x, y, z are IID exponential 1, exponential distribution with parameter 1. So then like w1 is x plus y plus z, w2 is x plus y by x plus y plus z, that means it is x plus y by w1. So that means x plus y is w1, w2, and w3 is x by x plus y. So and x, so that is nothing but x by w1, w2. So that means x is nothing but w1, w2, w3. So in order to find the joint distribution, first like we can express x, y, z in terms of this w1, w2, w3. So if we do the inverse transformation over there, so x is nothing but w1, w2, w3. So y is nothing but x plus y plus z. So x minus xy will give us y. So therefore w1 w2 times 1 minus w3 will give us like what is y, and z is nothing but x plus y plus z minus x plus y, and x plus y plus z is just w1. So w1 minus x plus y. So x plus y is w1, w2. So therefore w1 into 1 minus w2 is our z. So therefore our Jacobian, so if we compute the, and also like if we consider the domain conditions, so w1 is x plus y plus z, so w1 is just greater than 0, and w2 is x plus y by x plus y plus z, so the denominator is higher than the numerator, so therefore 0 less than w2 less than 1. And for the third case, x by x plus y, so denominator is less than the numerator, so 0 less than w3 is less than 1. So if we compute the Jacobian here, which is dou xyz by dou w1, w2, w3, so determinant, the absolute value of determinant of this partial derivatives. So it gives us the matrix, so this is nothing but dou x by dou w1, dou x by dou w2, dou x by dou w3, dou y by dou w1, dou y by dou w2, dou y by dou w3, dou z by dou w1, dou z by dou w2, and dou z by dou w3. So that is nothing but, so differentiation of x with respect to w1 is w2, w3, and with respect to w2 is w1, w3, and with respect to w3 is w1, w2. And this one would be w2 into 1 minus w3, and z if we differentiate it is 1 minus w2, and y if we differentiate with w2, so that is w1 into 1 minus w3, and z if we differentiate we will be getting minus w1, and this one doesn't have any w3 component, so it is 0, and here it is minus 1, so minus w1, w2. So the determinant, so J, the determinant would be, or like just determinant of this matrix would be, so w2, w3 into 0 minus w1 square w2 minus w1, w3 into 0 plus w1, w2 into 1 minus w2 plus w1, w2 into minus w1, w2 into 1 minus w3 minus w1 into 1 minus w3 into 1 minus w2. So that means this is nothing but minus w1 square, w2 square, w3 minus w1 square, w2, w3 into 1 minus w2 plus w1, w2 into minus w1, w2 plus w1, w2, w3 minus w1 into 1 minus w2, w3 plus w2, w3. So that is nothing but minus w1 square w1 w2 square w3 minus w1 square w1 w3 plus w1 square w2 square w3 minus minus w1 square w2 square plus w1 square w2 square w3 minus w1 square w2 plus w1 square w2 square plus w1 square w2 w3 minus w1 square w2 square w3. So if we consider this expression, so minus w1 square w2 square w3 will get cancelled with this, and minus w1 square w2 w3 will get cancelled with this, and minus w1 square and these two will get cancelled. Sorry, this won't cancel with this. So minus w1 square w1 w3 will get cancelled with this one, and then this will get cancelled with this. So we'll be left with minus w1 square. Sorry, like I don't think here we'll be getting this minus. Sorry, just a minute, let me once recancel. So we are having this is w1 square w2 square w3 will get cancelled with this, minus w1 square w2 w3 will get cancelled with this, and w1 square w2 square w3 will get cancelled with this, and minus w1 square w2 square will get cancelled with this. So we will be left with minus w1 square w2. So therefore the absolute value, so Jacobian here would be absolute value of this, so that is nothing but w1 square w2. So therefore now like we can find the joint PDF. So joint PDF of xyz is fxyz of small xyz. So that is nothing but e to the power minus x into e to the power minus y into e to the power minus z. That is nothing but e to the power minus w1. So this is the joint PDF of xyz. Now if we have to find f w1 w2 w3 of w1 w2 w3, so that is f xyz of xyz of Jacobian. So that is e to the power w1 into w1 square w2, where w1 is greater than 0, 0 less than w2 less than 1, and 0 less than w3 less than 1, and 0 elsewhere. So therefore this joint density of w1 w2 w3 of w1 w2 w3 is w1 square w2 into e to the power minus w1, where w1 is greater than 0, 0 less than w2 is less than 1, and 0 less than w3 is less than 1. So now like we can use this to find the marginal densities. So marginal densities f w1 of w1, so that is nothing but integral 0 to 1 and integral 0 to 1 w3 dw2 of w1 square w2 e to the power minus w1. So that is nothing but w1 square e to the minus w1 integral 0 to 1 w2 dw2 integral 0 to 1 dw3. So we can see this is nothing but w1 square e to the power minus w1 into this is nothing but 1 by 2 and this is nothing but 1. So if we see this is 1 by w1 square by 2 into e to the minus w1. So if we can see it is of the form gamma density where lambda is greater than 0 and 0 less than x less than infinity and 0 otherwise. So we can clearly see it is following like gamma with shape parameter 3 and scale parameter 1. So the marginal distribution of w1 is gamma 3 and 1. Now for the second case, this is 0 to 1, 0 to infinity, w1 square w2 e to the power minus w1 dw3. So that is w2 of integral 0 to 1 dw3 integral 0 to infinity w1 square into e to the power minus d1 dW1. So that is nothing but W2 into, so this is nothing but 1, and this is gamma of 3. So that is W2 into gamma of 3 is nothing but 3 minus 1 factorial, that is 2. So that is 2W2. So we can rewrite this thing as 1 by 2 into W2 whole to the power 2 minus 1, 1 minus W2 into 1 minus 1. So that's nothing but beta 2 comma 1. So therefore FW2 of W2 is 2W2, and 0 less than W2 is less than 1, and that is following beta distribution with parameters 2 and 1. Now for the third case, FW3 of W3, so that is nothing but integral 0 to 1, integral 0 to infinity, W1 square W2 e to the power minus W1 dW1 dW2. So that is integral 0 to 1 W2 dW2 into integral 0 to infinity W1 square e to the minus W1. So this is nothing but 1 by 2, and this is, this is 1 by 2, and this is nothing but gamma of 2. So which is nothing but 1 by 2 into 2. This is gamma of 3, not gamma of 2. So this is gamma of 3. That is nothing but 2. So this is 1. So that means FW3 is 1, where 0 less than W3 is less than 1. So that means this is following uniform distribution. So now, like, if we consider, in order to check the mutual independence, we can quickly check. So we can write the joint distribution that we got earlier. So I can write this as W1 square e to the minus W1 by 2 into 2W2 into 1. So if we see, this is similar to the distributions that we got earlier. So that means this joint PDF factorizes as the product of marginals, and the joint density factorizes as product of these individual marginal distributions. Therefore, we can say W1, W2, W3 are mutually independent. So that's it for this video. We'll meet in the next video.